4.1, we're talking about normal distribution. So when data is normally distributed, we put all that data, what we call a standard normal curve, and it's just symmetrical. It's all laid out evenly. Sometimes we kind of fix it so it is even because then we can find more information about it. So it's centered on the mean. So this line right here is the mean, and then each of these other lines are what we're calling standard deviation. Maybe you remember that from 9th grade, but standard deviation is how far away from the mean we are. Okay, so this is 1 standard deviation, 2 standard deviations, 3 standard deviations, and then we can go 1, 2, 3, and the plus or minus is just if we're going up from the mean or down from the mean. Okay, so one thing we do is there's a rule that you're going to see in a lot of your self-checks, and we call it the 68, 95, 99.7 rule. So that means 68% of the data is within 1 standard deviation. And I'm going to write it out just so you can see. So, and that's this part. 34 plus 34 is 68. So 68% is 1 standard deviation away from the mean, positive and negative. And then 95, that's within 2 standard deviations. So that's from here to here. If I take 68 plus 13.5 plus 13.5, I'm going to get 95%. Then can you guess the last one? 99.7. That's within 3 standard deviations. So that's here. So from here all the way to here, if we add all those up, and this one rounds, so it's not exact, but it's 99.7. Okay, so mine I took a rounded one. This is actually 2.35, and this is 2.35. That's where the 7 comes from. Okay, so this is what we call the standard normal curve, and we're just going to do some problems that relate to that. Okay, so a survey asked 200 people how many hours a week they spend watching television, and the responses are normally distributed. Okay, here's what we need to know. The mean is 13 hours. So right here, this represents 13. And the standard deviation is 3. Okay, so that tells us what to add or subtract from the mean. So for 1 standard deviation, we're going to add 3. So this line represents 16 hours. This line represents 19. Do you see I'm just adding 3? Adding 3. This represents 22. Then we do the same thing back. So this line would be minus 3 because we're going backwards. So that would be 10. This line would represent 7 minus 3. And this line would represent 4. So that's how we label it. The mean plus or minus the standard deviation. Calculate the number of people that watched between 10 to 16 hours of television per week. Okay, so let's go find those numbers. We want between 10 and 16. So this part. Well, this is 34% and this is 34%. So 34 plus 34. We want 68% of the people. Well, how many people are there? So 68% of 200. Alright, there's a couple ways to do this. If you're using Desmos, you can just say, I want 68% of 200. If I type percent, Shift 5, the of just shows up. It's 136. If you're not using Desmos or you like it the old-fashioned way, you're going to take 200 and you're going to multiply it by 0.68. Remember, to get rid of a percent, we move the decimal back twice. Either way, you're going to get the same answer. All of my notes show the old-fashioned way. But remember, with Desmos, it kind of takes some of that out. So what this means is 136 of the 200 people watch TV between 10 and 16 hours. Because the data is normally distributed. We can find that out pretty quick. Okay, one more thing I need to add on here is like a big note. Since we're normally distributed, so since data is normally distributed, the mean, the median, and mode, motor and mode, remember those are three measures of center, mean, median, mode, are all equal. They're all the same number. So for this question, 13 is the mean, 13 is also the mode, and the median. You're going to get a question about that.